So now let's head into our next user facility. Apurva Mehta is a lead scientist at SLAC National Accelerator Laboratory and has over 25 years of experience. He's going today to talk about the Stanford Synchrotron radiation light source and how you can leverage those resources at SLAC. So Dr. Mehta, the floor is yours. Please, we're excited to hear more.
Thank you, Lindsay. Thanks for the introduction. I think it's a great session to be. I think some of the things that Brandon said were also very interesting and applies to across the labs, I think. So I'll sort of hit on some of those points out here. Let's see if I can control my slides. So what I really want to talk about is how national labs and specifically SLAC is interested in solving real world problems with a partnership model that we are sort of developing. So going forward, I mean, you have heard about various different ways of accessing the lab. I'm going to talk today mostly about the last point, but all the labs have all these different ways of partnering with people from industry and from other academia as well. So let me sort of go straight into this. It's a busy slide, but I want to sort of tell you about two different ways of accessing the lab. One is that we have tools and instruments, and you can access them. And as Brandon mentioned, those are free. You write a proposal and you can get access to all of them. Those are, and we help you write the proposals if you need any help with that. But the thing that I really want to talk to you about is we have expertise. Again, something Brandon touched upon. There are scientists out here that help, that do things, and we have expertise in many things at SLAC. We have expertise in batteries and PVs and alloys. We are beginning to do a lot of work on devices. Microelectronics is a big focus up here. Also, we just got a new center for doing quantum devices. So we have a quantum foundry in collaboration with Argonne. So we're doing a lot of that. Energy generation, storage, catalysis. We do a lot of protein crystallography. So we look at viruses, protein structures, drug discovery. So we did a lot of work on looking at COVID-19 protein structures and how they work, what are the mutations that come through that. Geology, environmental remediation. It's an accelerator lab, so we do a lot of things with RF technology, not just accelerators, but things like communication satellites and all of those technologies. We have a large program in doing electrical grid and grid integration and smart grids and controls on that. So all the way from controls to putting devices on the grid that can allow those kind of controls to happen. And then finally, we started an institution on machine learning and artificial intelligence. I'll sort of say a very little about that. Stanford has a strong collaboration part in that, so I'll talk about that a little going forward. But the final thing I want to sort of talk about is we have friends who are experts. Some of us are experts, but we have friends who are experts, and we work across the lab. So that's sort of what you get by leveraging and working with us. So going forward, we have lots of tools. If you know how to use them, you heard about them, we can help you access them. We can help you write proposals to get access to them. We can help you use them. We can help you even probably analyze data coming from them. And this is sort of a short list of some of the things that we've sort of done in the past using these tools, but this list is very, very small, right? So we looked at, with the industry, we are looking at lithographic mirrors and how they form, or we are looking at how batteries operate or fade, or we are looking at how microelectronic processing happens. So we look at how drugs can get developed and how we develop new drugs with some of the industries in the Bay Area and across the world. We look at how biomedical devices fracture and fail. I'll talk a little bit more about this in the end. So there are many, many things that we sort of do, which are in this tools and instrument section. So as Brandon mentioned, access to many of these labs and facilities is through a peer-reviewed proposal, and it's free if you're willing to publish, but there's also a proprietary pathway. So even if you write a proposal and you don't want to disclose everything that goes into it, there are ways in which you can sort of do something slightly in between no cost and cost. So our instruments are running on those things run on full cost recovery mode. So you're paying few $100s an hour. About $300 is probably the about amount it comes for an hour for accessing some of the instruments. And then the stuff that you do is protected by IP agreement with SLAC and Stanford. So that's the way you can sort of use our tools and instruments. But I want to sort of, in the next couple of minutes, talk about the other way you sort of access us and other labs. And that's through expertise. So many of us come through this as domain scientists. So I was a material scientist. I'm still a material scientist. I do a lot of material science as my second job at SLAC. So we have some of the expertise that you can leverage. We can work with you in collaboration with that. Other thing that is really interesting and important is SLAC has over 2,500 users coming in every year from all over the world. They're world experts, and we get to know them. We get to know some of their problems. So we may not have expertise, but we have connections to experts. So we can put you in touch with other people. We can say, hey, I don't know anything about this, but so-and-so at UC Davis or so-and-so in such an industry knows this problem. Maybe you two should talk to each other. Maybe we can help that thing happen. Other thing that I want to sort of also say is SLAC is a division of Stanford, and Diana can tell you more about that. So through that, we have a very, very strong connection to Stanford. So SLAC, through that, you get access to a lot of the resources that Stanford has, a lot of the expertise Stanford has, and then sort of going forward. And I haven't put that on this slide, but I'll sort of talk about it in my last example. We work across the lab. So for me personally, I have done measurements at ALS at the Berkeley lab. I've also done some work with Livermore. So we work together across the DOE complex. It's not you come to one lab and you can't go to the lab. Sometimes we sort of go across the facilities to see where the best science gets done. So we work together as a large DOE complex. So if you have problems that you want some help on or some thinking, come talk to any of us, and we can try to sort of figure out either if you can use our facility to solve them, or we can find some experts who can help you, or we can probably send you to some other people that we know across the lab who can probably help you do that as well, right? So I just want to end by talking about this one particular example. It's a very busy slide. I'll just sort of talk about it very, very quickly. I want to sort of talk to you about how this kind of collaboration comes across. So starting from the left, this was a company, was part of Johnson & Johnson in those days. And they were trying to figure out why biomedical stents fracture in vivo, so in your body. Putting them in is easy. If they break, taking them out is not that easy. It requires a surgery. So how do you figure out how they fail and what can you do about this? I'm not going to go into the science on that, but we sort of work with the company very closely to try to figure out what kind of experiments we can do on that, come up with a strategy that sort of brings up some understanding, and some sort of a strategy that company then eventually took and then redesigned their stance and had a new design philosophy that sort of helped them develop this thing going forward. So it was very exciting for us because we got several graduate students working on this, lots of really interesting publications, but also it was the insight that that came from that allowed the company to actually do something really interesting as well. It also made FDA very happy because FDA now knew why this stents work. So getting regulatory bodies to support some of the things that you are doing, this kind of research becomes really, really important. So this thing started by the CTO of the company coming and talking to us, right? And then we sort of had series of meetings, and then based on that, we started devising feasibility experiments, and then finally full-fledged experiments that we sort of ran. We ran some of them initially in my lab, but then we decided that some of the measurements that we want to do, especially the ones that you see on the right corner, we thought that there was a beamline at ALS, and I had a collaborator that was very good at that. So we actually took these measurements and we did them at ALS. So this combination of different labs, different instruments across the complex is sort of how we managed to solve this problem. And so this is really fun. It's fun for us as well, because I learned a lot about cardiovascular stents and what really happens in a body. So I want to stop there and sort of say that this is just a short list of the companies that have sort of used our facility over the last year and a half. You can notice that the second company, we haven't disclosed the name, and we sort of work on that kind of thing. I want to let you know that, if you come and work with us on a no-cost basis, still, if you want to protect your identity or protect that what you're doing with us, we have mechanisms for doing some of that. So I'll end there, and thank you for the time and for listening to me. Thanks.
Yes, thank you, Apurva. We appreciate it. And of course, you'll be sticking around to answer some Q&A. And Diana from SLAC is also answering that Q&A. So thank you for presenting.